Hello students, our next topic is laws of radioactivity. So what is an activity? The activity of a sample of any radioactive nuclide is the rate at which the nuclei of its constituent atoms decay. It is the rate at which the nuclei of its constituent atoms decay. If n is the number of nuclei present in the sample at a certain time, its activity is given by activity is symbolized by letter R is equal to minus dn by dt. Okay, what is n? N is the number of nuclei and dt is that during the time what is its change in activity. The minus sign is used to make R as a positive quantity since dn by dt is of course negative. Right? Now the SI unit of activity is becquerel. 1 becquerel is equal to 1 BQ, 1 dk per second. Traditional unit of activity was QCI. 1 QD is equal to 1 CI is equal to 3.70 into 10 raised to 10 decays per second of 37 giga becquerel. Now what is half-life? Less and left, but always some left. Every radionuclide has a characteristic half-life. It is the time taken for the amount to become half of its original amount. That is half-life. The time taken for the initial amount to become half of its value. Some half-lives are only a millionth of a second, others are billions of years. One of the major problems faced by nuclear power plants is the safe disposal of radioactive waste, since some of the nuclei present have long half-lives. Now, the activity versus time graph. It exponentially decreases with time. Okay, the activity of a radionuclide decreases exponentially with time. So, accordingly, we write an equation for activity as the activity law is defined as the activity law R is equal to R0 e raised to minus lambda t, where lambda is called the decay constant. It has a different value for each radionuclide. The connection between decay constant and half-life is very easy to find. After half-life, T will be equal to T half. So, the activity R drops to R0 by 2. R is the activity, it becomes R0 by 2. Hence, I'm substituting those two values. R is replaced as R0 by 2 and T as T half. You get the relation. Solving, we get T half is equal to ln2 by lambda or 0.693 by lambda. This is the equation for half-life. 0.693 divided by lambda, the decay constant. Okay, this is a relation which is needed for our problem solving. Right? Next, radioactivity in terms of number of nucleus. You know the activity law follows if we assume a constant probability lambda per unit time for the decay of each nuclei of a given nuclei. Okay. With lambda as the probability per unit time, we take lambda as the probability per unit time. Lambda into dt is the probability that any nucleus will undergo decay in a time interval dt. So lambda dt is the probability that any nucleus will undergo decay in a time interval dt. Now, if a sample contains n undecayed nuclei, the number dn that decays in a time dt is the product of the number of nuclei n and the probability lambda dt that each will decay in dt. That is, dn can be written as minus n lambda dt, where the minus sign is needed because n is decreasing with increasing time. Okay, so this we can relate radioactivity in terms of number of nuclei. By this equation, we can write as dn by n is equal to minus lambda dt. On integrating on both sides, we get the radioactive decay in terms of the number of undecayed and number of nucleons. Right? N is equal to n0 e raised to minus lambda t. This formula is the number n which is the number of undecayed nuclei at time t in terms of the decay probability per unit time lambda of the nuclei involved, and the number n0. N0 is the undecayed nuclei at time t is equal to 0. So, at a time t, what is the number of undecayed nuclei is given by this equation. Now you go through this example problem and write it down in your notebook. Next is mean life. So what is mean life? T bar. The mean lifetime of a nuclei is the reciprocal of its decay probability per unit time, or T bar is defined as 1 by lambda. Hence, mean lifetime is equal to 1 by lambda, that is equal to, we know the equation for T half, and substituting that, you get T half by 0.693 is the mean lifetime T bar, that is equal to 1.44 times T half. This is the relation connecting mean life and half life. This is also an equation needed for solving problems. Since the activity of a radioactive sample is defined as R is equal to minus dN by dt, we see from the above equation mentioned R is equal to, on differentiating this, we get lambda and 0 e raised to minus lambda t. This agrees with the activity law, as if R0 is equal to lambda and 0. So our equation for activity was R is equal to R0 e raised to minus lambda t. So if you replace lambda and 0 as R0, you get the same relation. You get the activity law. So in general, activity R is equal to lambda n. This is also a relation needed for problem solving. Okay.